This is medium energy 6. These are the areas that we use for developing and testing our hardware and pulse power circuits that are used to drive our fusion generators. What we are trying to do with the Orion Demonstrator Circuit Unit is replicating a circuit that is gonna go into Orion Bank and replicate the hardware and validate all those hardware along the way. We make this hardware in an integrated way. We can go and individually test all the hardware, but the challenge here is when you integrate this as an integrated system, how are they gonna function? How are they gonna couple together? One of the major goals of this project is understanding how this whole hardware as an integrated system is gonna work and how we can replicate the hardware and test it efficiently and faster, and how we can characterize the hardware so we know what the hardware is actually doing. The requirements for the Demonstrator Circuit Unit are different from Polaris because every single generator that we build, it has a different mission. We built Polaris to prove that we can generate electricity and put it back in the capacitor bank. We are going to make Orion proving that we can actually reliably and repeatably deliver that electricity to the grid and keep doing that over and over. We broke down the machine requirements to smaller levels, to like the capacitor module level. At the lower level, we knew what kind of cooling system, for example, we want to implement. We knew we want to go and get rid of a lot of the cables that we use for Polaris. So we knew that we have to go and develop that technology. We knew that we have to go and work on new triggering architectures for our switches. And now we are working on those, and Demonstrator is a platform that actually proves all those technology are working the way that we want them to work. We have several major goals for this project. The first is hitting the efficiency targets that we want to have in the machine. The second is replicating the waveform that we are putting on the circuit and replicating the waveform that goes into the Orion bank. We have very high reliability targets that are needed for implementing a power plant, and we are testing those reliability targets in this project. The other major goal for the project is rep rating. We know that Orion machine is going to be a repetition-rated power plant, and because of that, we want to qualify our hardware and design it such that it can be rep rated and it can replicate the rep rate that we have for the whole machine. The Demonstrator project has 3 different phases. In phase 0, we actually go and test individual components and we qualify them to the circuit levels that we expect from the circuit unit in the Orion Demonstrator. For phase 1, we go and integrate all these subcomponents together and we test them in an integrated way to understand how these things are going to affect each other, how the whole integrated system is going to operate as a unit. For phase 2, we go and make a more complicated system that is including multiple of these circuit units operating in parallel, and we try to understand what is the fault tolerance of the whole system, how we can handle the safety of this system, how do these systems operate when we put them in parallel, and how are they going to impact each other. When we go through all these phases, we have new learnings that we have to go and implement in the next phase so our testing doesn't break and we can qualify hardware faster and more efficiently. A lot of times as we go through these hardware dev cycles, we come up with a lot of problems that are new and we have to come up with creative solutions to solve them. For example, we constantly try to reduce the complexity in assemblies and making systems that are more manufacturable. For Orion, we knew that we want to go and reduce the number of the parts that we are using, and particularly one of our engineers came up with this brilliant solution, introducing this new bus bar system that relies on layers of sheet metal that are enclosed with insulating plastic. That allowed us to reduce a lot of parts from our capacitor modules, and it also allowed us to increase the efficiency of the circuit and reduce the resistive losses. Our capacitor bank is made out of a lot of complex hardware that have to be integrated together very efficiently and very quickly. As we go into Orion, we want to make sure that we go and qualify those hardware and we have enough design maturity so we actually can put that hardware on our production line and we can build the machine as fast as possible.